start now. Hi, so today we're going to give you some insight into the way that Workday builds our Kubernetes distribution. And that's me, I'm Simon, Shatadru and Jan. We are engineers on the private cloud team inside Workday. So what we're doing mostly today is OpenStack. And on OpenStack, our clients, our internal clients, run many VMs. And we're looking to push them more towards a Kubernetes world. So to give you an idea of the OpenStack deployment that we're looking at, on any given day we've got about 120,000 VMs across 180 odd clusters. And I think the interesting stat that we've got is we do about 750,000 VM teardowns and builds in any given week. I think that's why we have the 180 clusters, because we found that just for scaling and for our purposes, that's what we need. So today we're going to be talking about our Kubernetes distribution. Shatadru will be going through how we test parts of that, and Jan will be going through how we run the Zuul Operator on top of the Kubernetes distribution that we've got. So first of all, why do we need our own Kubernetes distribution, and really what is the distribution? We have a Kubernetes cluster, and inside Workday, we have a number of pieces that we need to speak to. So we need to speak to the storage components, we need to speak to our external DNS components, and those are all wonderfully custom written parts of the Workday infrastructure that we need to work with. So whenever we looked at taking something in, like EKS or OpenShift or any of the other pre-built Kubernetes clusters, it never really quite fit. So effectively what we've needed to do is build our own Kubernetes infrastructure so that the public cloud side of Workday's business, which is another team, they're quite large, who've already developed all of their Helm charts, can effectively pick up their Helm charts and they can move them into our private cloud. So what does it actually look like, and what does the Kubernetes side of things look like? We have a small Kubernetes cluster that we call a service cluster. We install that using Ansible, because that's well tested in Zuul, obviously. So we have a small service cluster, which we then install a bootstrapping Argo CD instance that runs a very small set of charts. And then what we do is we apply our distribution. So a distribution is the Argo app of apps that contains all of the Helm charts that are configured and built to run our Kubernetes cluster. So it pulls in external DNS, and it configures it to speak to our DNS client. It configures the storage components and all of the way that we're going to actually run our Kubernetes system. So there's lots and lots of Helm charts wrapped up in that distribution. And then when we want to upgrade, what we do is we go to that app of apps and we change the number of it, because we've produced a new version with Zuul. And then what we do is wait for Argo to sync up, and hopefully everything works well. On the side, what we've done is we've installed, using Ansible again, a number of other worker clusters. And those worker clusters are the ones we're actually going to run our customers' workloads. So our service cluster is using Argo to control and deploy everything to our worker clusters. We rely heavily on Capo to do scaling and to do management. With inside the Kubernetes clusters. So if we need new nodes, if we need new controllers, if controllers need to be reset, that's generally how we're doing that. So each of those components that go into the distribution is its own little Garrett repo, and Zuul is the thing that is coming along and actually testing that out. So the three things that we've learned from doing this is, first of all, Argo CD. When you put in your bootstrapping Argo CD and you're trying to build up that distribution of deploy this chart and deploy this chart and deploy this chart, it's not going to go in the order that you want unless you very closely manage the syncing of that, and you will end up with Kyverno deploying something. And we've seen that primarily when a cluster accidentally reboots, that you have a Kyverno webhook that won't allow admission of another pod. So you need to make sure that when Zuul's running things, it can sync things in a specific order, and that when you're deploying to prod, that you can actually do the same with the Ansible tool we've written. Maintaining your cleanup is very important. So when we run our Zuul jobs, we have Zuul spin up one node pool node, it runs a kind cluster, that kind cluster then creates using Kappa the rest of the clusters. Those resources are obviously not looked after by node pools, so unfortunately we need to then, if the job fails for any reason, ensure that our cleanup scripts are working the way that we need them to. And the last thing is, and this is mostly actually more of a lesson from an OpenStack side of things, where we're maintaining the tests, well-isolated tests that you can put together inside Zuul, so you can run this playbook and this playbook and check. You might run more gate, you might run less gate, you might run this, that, and the other. But the idea is keep your jobs very separate so that you don't end up with a 3-hour deploy job that hits timeouts and that you have fun maintaining over the years. I guess they're the 3 things I've learned anyway.
Thanks, Simon. So I'll be talking about how we build and test our Kubernetes distribution, and how we kind of leverage Zuul to do that, and how and some key takeaways basically from building our own Kubernetes distribution. So early in the development, when we started with our new Kubernetes platform, so we have decided to kind of like separate our applications into different categories. One we call infra app or infrastructure application, which are basically building blocks for our Kubernetes platform. So this includes some of the usual suspects like Kaizen for policy, Cilium for ingress and networking. We have Ceph CSI for storage because we have Ceph and things like that. And we also have like normal application which are just regular application running on top of our Kubernetes platform. One example is Zuul is one of the first things we ran in our Kubernetes platform, and Jan will talk about that part. So why we are talking about the difference? It's because testing this infra apps are slightly different from testing regular application because they need higher privilege and they are created during the cluster creation. That means that, like for example, if you want to test our components, we literally have to create and delete a Kubernetes cluster every time we make a change. Because we cannot simply just use, say, the node pools Kubernetes driver because they will be cluster scope. In contrast, the regular application are always namespace scope, so we can easily test it using the Kubernetes driver, even though we cannot do that now. So some more details due to our internal requirements. We are actually not building one Kubernetes distribution, but we are actually creating rather multiple slightly different versions of our Kubernetes distribution based on the environment, based on like different teams, because they have different requirements obviously, or different clusters, which obviously comes with unique set of testing challenges. So here's a sneak peek on how we build and maintain these slightly different versions of our Kubernetes distribution. So we broadly divide our platform configuration in 3 different repositories. So the first one is obvious. This contains information regarding of our clusters and environments, for example, which data center it is running on, and so on, data center specific configuration. Then we have team information, which have information regarding to the service teams and what their Helm charts are, and information specific to the internal application team. And then we have profiles. So profiles are basically flavors of Kubernetes cluster we are deploying. So one example would be we have staging clusters, we have service cluster like Simon mentioned, we have management cluster, and different profiles like beta, production, and so on. So as you can see, depending on the cluster and the team and the profile, we would have slightly different versions of these components in different clusters and different environments. So how we kind of solve this is we have decided to we have all these different components. So when a developer decides that, okay, I need to release a change, we basically add a release tag in our commit, and that triggers a pipeline which basically merge all the components and creates a final app of app Helm chart, which then basically is used to test everything put together in a new Kubernetes cluster. So, and based on which file basically gets changed in that merge repository, we will basically trigger that particular pipeline. For example, if I make bump in Kyverno in one of the development profile, it will basically trigger that particular pipeline. Again, we heavily rely on Zuul. One of the things we rely is Zuul's job inheritance. So we have a base job, which basically deploys a Kubernetes cluster and run all our tests. But then we also have like these different profiles, which basically inherit from the base jobs. We also have a more comprehensive version of this test, which will run things like conformance test to ensure our Kubernetes cluster conforms to the upstream standard. We also run things like policy testing because we use Kyverno to deploy policy. So we use Chainsaw to basically test our policy behaviors and things like that. We also have standardized testing pipeline to ensure all these small components adhere to a strict standard. Yeah, one recommendation we have, like if you are using Kyverno for policy, you should check out Chainsaw. It's a really good testing framework to test any Kubernetes operator or even basically any Kubernetes resource. So it's really cool. You can test things in a declarative manner, so you can check this one out. It's really cool tool to test things. Moving on, we have like different test frameworks to test our applications, the infra applications. We have functional tests, which basically gets triggered when there's a change in any of these components, like or our configuration of Cert Manager, that will trigger the pipeline to ensure like Cert Manager is working well and all the functionalities of the Cert Manager is basically working well. These also gets triggered in our release pipeline to ensure everything kind of works together. Then we also have integration tests, which basically kind of ensures all our core platform integrations like Ingress, PVC, and certs, everything kind of works together. And and then we also have like static test, which basically does check linting, schema validations, and things like that. So here's just an example of one of our jobs. I'm not sure if that's readable, but in the starting jobs, as you can see, are mostly static jobs, which basically does linting. And then we have the job which basically deploys a brand new Kubernetes cluster. It basically ensures all these applications kind of converges well. We also then run functional and integration tests to ensure everything and those particular versions of the components are kind of working well together. And then this is just an example I kind of wanted to show how we kind of use inheritance to test these multiple different, slightly different profiles in our deployment. Just want to mention some key takeaways because we are kind of building our own Kubernetes distribution. We again cannot use the node pool Kubernetes driver to connect to an existing Kubernetes cluster, so we have to build a new Kubernetes cluster every time. We are still kind of trying to find a balance between running more tests in the check and gate and making things take really long time, versus moving some of the tests to, like periodic jobs or even our release jobs, which again like means we might actually merge broken code, but we will at least catch them before they land in production. This also means that we have to use our custom janitor so that we don't leak resources because we don't know when those jobs will fail. And one interesting thing that we have faced in past was Zuul's credential management system was not what we kind of were expecting, so it was a bit weird. But now that we would be deploying new Zuul, we are really behind on our Zuul version. We are really excited to try out the new credential management systems. Another thing is kind of learning is Zuul's version of Ansible sometimes pushes us to use Ansible on Ansible or nested Ansible because we cannot sometimes use like say galaxies or for any other reasons. The other thing is that triggering pipeline in Zuul, apart from a code review, is tricky. It's not a problem, and like I've shown, we have kind of adapted well to the change in mindset. It's just a thing wanted to mention. And with that, I will hand it over to Jan. We'll show how we deploy Zuul.
Thanks. So I'll be taking you through our recent experiences in operating Zuul. We've been using Zuul 4.2 for quite a while. This is including building whatever Shatadru and Simon has been talking to you about. So Zuul is extremely powerful, but with the new platform, a new Kubernetes platform, we got an opportunity to update our Zuul and apply newer stuff to it. This diagram gives you a little bit of the idea of the pipeline we built to build and update Zuul. The nice thing about this is we don't suffer from the bootstrap problem because Argo CD manages Zuul and Zuul manages the Helm charts that Argo CD deploys. So we have two entry points to fix things. We hope that they are at least enough. So we built Zuul containers from scratch. This is mostly because we live inside an isolated environment. We don't have all the repos available to us in our build system. We build, test, and release them, and then we have a chart that we built a generic chart that allows us to specify a generic instance of Zuul. This is important because we use that generic chart in the app of apps Helm chart. So this would apply to any other application, generic Kubernetes application that you would use, and we test the generic application pipeline that way. Then we build ourselves a staging version of Zuul and a production version of Zuul out of that Helm chart. The nice thing about this is we've gone through this entire thing at least once, so we've built Zuul on it at least once and ran that version of Zuul on it. Every single one of those steps is in effect a tiny little CI pipeline, which you can restart at any point. And this looks like a line, but it actually should be a little bit of a circle because we want to do our updates much more regularly. So the individual stages here, we start off with building upstream Zuul, Zuul containers. My first recommendation is use the upstream Zuul Zuul containers. They're really high quality. The guys who built them know what they're doing. The second one is if you cannot use them and you need to modify them, there is really good tooling available with the OpenDev builders. You can add a lot of customization there without too much trouble. And also, if you really are need to do that. You can build your own. The tooling there is completely visible on OpenDev. They have some very good roles and jobs that show you exactly how to build containers using Zuul and do releases and everything like that. Virtual machines are still a really, really nice way of building containers. I believe they still provide a lot of advantages above containerized builds. So for our build job or our project, this is a really, really simplified. I think I removed like 5 lines out of our job. So you can get by with some really, really simplified Zuul config. The nice thing about this is if you design your build and test jobs, build and release jobs correctly, you can just use include vars for an entire group of projects and just manage the extra bits over there, like the container names there. So the nice thing about this is we can do things like ensure that the check jobs, gate, and periodic jobs align. This is reasonably important if you're building Zuul, because Zuul doesn't have the same upstream OpenStack cycle-wise upper constraints. So you need to check that your builds keep on working, because Zuul has also got a lot of dependencies upstream that if they start breaking, you need to be able to catch that, otherwise you're out of luck. Hence why using the upstream containers is a good idea. So the build job here, we have the advantage of having an external artifact repository. So the external registry allows us to age them out. So we just set an age policy. We upload the artifacts for the test job and register their locations in the Zuul artifacts. Very easy for us, because that allows us to ensure that we don't need to keep any registries running during the middle of the job, but you need to have a registry system for that. The trick is that we have some, if you do need temporary registries, Zuul jobs, again, there's some really, really good examples of how to set up a build set registry that's available for you to do your testing. The other feature here is we have some tooling that automatically generates versions, because our developer workflow tends to work that way. In this case, we just register the proposed version inside the build job, and in the next job, the promote job, if that runs after the build job is merged, we check with the Zuul API using that little Zuul job over there what the release was. So this is all pretty much standard. You can see this. You can see tons of examples on this in the OpenDev pipeline. Really, really cool things. So then all that we do is we take the list of containers that we built, we move them to the release location using Scopio, and then we apply the git tag to the repo. And this is really nice because we can keep the promote code to a minimum, which is they're difficult to test because promote jobs tend to run post-review. So those jobs, anything in the trusted context in Zuul, you want to keep to as small as possible. We use the Zuul Operator. It's a COF-based Python operator, and it is good at bootstrapping a Zuul instance, getting it run up very quickly in Kubernetes for you. Once it's up and running, its primary function is to allow you to roll out updates in a smooth fashion. It's still a little bit, we still have a downstream fork of this. We still need to update the templates inside it and so on. There's still some work that we'd like to do on this. I encourage anybody who wants to play around with the Zuul operator, build it yourself and start contributing upstream to it. It's the only way it's going to get better. We wrote a Helm chart for the Zuul operator because installing it using Argo CD installs it using Helm, and then obviously we take the Helm chart and we fill in the values for the specific instances that we want to write. And that we package up again into the App of Apps Helm chart. So this allows us to ensure that we don't have a lot of drift. Zuul is just another application side by side by a bunch of other things that we run at the same time. We've talked about how the App of Apps get built. Zuul is basically just one of the normal tenants there. And let's see. In this case, I'm going to show our ignorance by, I have a quote from a previous colleague here that said, everybody has a testing environment, and some people are lucky enough to have a totally separate environment to run production. So this is a signature of exactly why, if you need to be smart enough to have your production environment or to not need a staging environment. We're not smart enough to not need a staging environment. The nice thing about us is because we already target multiple clusters and multiple environments, it's a lot less resources for us to build a staging environment. Also, excellent ways of teaching people how to break stuff without bringing down production. So finally, after we've adopted 5 years of upgrades in one go, Zuul has progressed a lot. If you've seen some of the previous slides, previous things that the BMW folks got, things that is going to be in the talk just after this, Zuul has been excellent to us, and Zuul has just gotten better. Time will tell though if we manage to keep the pace of updating Zuul up. At the moment it looks like we can easily roll out production Zuul from the current version. So if I show you a version of ours, it will look exactly the same as the one that's running on OpenStack. And these are just a list of things that are now unlocked. Whether we get to do them, I would really like to get to do them. Highest on the list is obviously Notable and Zuul, because that's a big improvement. Hacking on the Zuul operator is definitely going to happen, whether we do it nicely or quick and dirty. I really hope it's nicely. And it's also likely that we'll do similar kind of treatment to Garrett. And finally, thanks for coming. Workday is celebrating its 20th birthday this year, and we have some pins left. We used to have 20, but they're now a little bit fewer. So after the questions, please come and grab some. Any questions?